Alright, you guys, we are going to talk about direct variation with this lesson. I've already typed up some things on there, so you can go ahead and start writing those down or pausing the video so that you can get those down. Up here under direct variation, there's a star. It is a linear pattern that must pass through the origin. I'm going to write down linear under the review for you because you should have been working on that last year. Remember, a linear relationship was a straight line. You could represent it graphically, numerically, or algebraically. What that means is graphically, numerically means as a table, and algebraically means as an equation. So we're going to do that same thing with direct variation. It's a specific type of linear relationship. It can be used to represent any ratio, rate, or conversion factor. And if you remember, I think from the very first video we did in this series of proportional reasoning, we talked about all three of those words. New under academic language tonight is constant and origin. So a constant number is a number in the equation that's always going to stay the same number. That's why it's constant. And the origin is talking about the origin of a graph, which means where y and x equals 0, right in the middle of the graph. So we'll get to there in a minute. But let's move on. Let's start this off with an example, and let's start the example off with an equation that represents a direct variation. So the equation I chose was y equals 1.5x. So 1.5 is k. Okay, and that k stands for, oops, look what I did. I wrote this as a k where it should be a 5. 1.5 equals k. K is that constant, okay? And k stands for, it's called the constant of variation. Okay, so under, as a reminder, constant of variation. Okay, and under linear, right next to linear under the reminder, I want you to remember y equals mx plus b, because that's something we know, and this is going to look very similar to that. You will see, though, that it's missing something. We have the y here, we have the slope, although we don't call it the slope here, we call it the constant of variation, and we have the x. What you do not see is that b. There is no y-intercept in the equation for a direct variation because it always goes through the origin or goes through the middle of the graph. So this is a direct variation equation, okay? Or a algebraic representation. Okay, because we'll use that a lot. You'll notice we use algebraic representation a lot in our CLOs at the beginning of the day. So what does this look like as a table? And while I'm talking about this, I want you to remember you did so much work last year on linear relationships, okay? A table is also a numeric representation, okay? Good. So what does this look like in a table? So we have our x and our y. Remember, x is the independent variable, y is the dependent variable. And let's start off, we know it passes through the origin, so we know it passes through 0, 0. And then our constant, what we are, well, let's see. And then let's just make this 1, 2, 3, 4. Okay, our x. So remember how you can put numbers into your equation? So if we put 0 in for x up here, it would be 1.5 times 0, which is 0. And now we can figure out the y if we put in that 1 for x. So that would be 1.5 times 1, which is 1.5. And then we put in 2 where the x is. So we have, it would be 1.5 times 2, which would be 3. And we put 3 would be 1.5 times 3, which would be 4.5. Okay. And 1.5 times 4, which would be 6. Okay. And you can also tell that we're adding 1.5 every time we make a bigger number in the y's part of the table, okay? One of the really interesting things and one of the ways you're going to recognize a direct variation is I'm just going to add another row to this table, and I'm going to call this row y divided by x. So I'm going to fill this out where every time I have some numbers, I'm going to take the x value and divide it by the y value. So here, now this is tricky. I don't know if anybody's ever told you this, guys, but you cannot divide something by 0. So it doesn't even exist here, okay? That doesn't even exist there. So, but let's do the next one. The next one would be 1.5 divided by 1, right? 1.5 divided by 1. Anything divided by 1 is going to give you that same number. So 1.5. Then let's take 3 divided by 2, and that's also going to be, guess what, guys? 1.5. What's the next one? If we take 4.5 and divide it by 3, we're going to get 1.5. And if we take 6 and divide it by 4, guess what? We're also going to get 1.5. What we're doing is kind of undoing the table that we just made. But this is really important because this is how you can tell if a table represents a direct variation. You can take that y value, divide it by the x value, and if you always get the same number, that's going to give you your direct variation. So let's put that over here in the reminders that y divided by x is always going to give you that constant, okay? So we have the constant here, what it stands for, and then we have how you get it right here, okay? So we have the equation, we have the table. Let's move on to a graph. And we're just going to graph that table. And this right here, this part right here, you guys, this is the origin. It's the middle. It's 0, 0. So every time I talk about the origin, that's, you know, what I'm talking about. So where did I go? I went up to 4 on the x value. So let's try 1, 2, 3, 4. This will be good review for you guys. And up our y value, our largest value was 6, right? So I now need to go up to 6. So 1, 2, 3, 4, 5, 6. And if you had graph paper, this would be a lot easier. So 0, 0, the origin is right there. I did that already. Oops, let me number these, you guys. And always remember, you put your number right next to the line, not in between the line. The number goes right on the line, okay? 1, 2, 3, 4, 5, 6. You should probably be pausing to catch up if you need to do that. So here x is 1 and y is 1.5. So x is 1, y is 1.5. There's going to be my first point. Then y, or x is 2, y is 3. So I'm going to come right where x is 3, y is 4.5. There we go. I had to come out there to get it perfect. When x is 4, y is 6. Okay. Here. Okay, so there's our points, and now if you connect those points, and I don't have a ruler here, so I'm just gonna, it might not be perfect. Right, we have our straight line that goes through the origin. So that's how you represent this with a graph. And while we're on this table, let's go ahead and label our axes. This is our X, this is our Y. I don't want to forget things because I'm always going to expect this stuff from you. So I need you guys, so I also need to do it for you, right, as a model. Constant origin. Let's make a note that over here under reminder, let's make a note that it must pass through the origin in order to be a direct variation. Must pass through the origin. Okay, and let's see if I'm missing anything here. Nope, your y divided by x is always going to be the same number. There is no y-intercept in the equation. Let's write that somewhere over in reminders. No y-intercept in the equation because it's a special type of linear relationship. And I think that that's all that I have in. Tomorrow, remember, save room at the bottom of your notes. And we're going to write our algorithm, or what we're going to do tomorrow is actually write how do we remember what a direct variation equation looks like? How do we remember what a direct variation table looks like? And how can we remember what a direct variation graph looks like? And how can, when we see those, how do we know it is direct variation? And that's what we're going to be working on when we go over this in class. Thanks for listening.